All right, good afternoon, class. Okay, today we're going to be going over the pH scale, pH, pOH, and we're going to go over how we calculate the pH and pOH. So this is lesson 14. Once again, welcome to class. I hope all of you guys did your homework. So today I'm going to quickly go over our homework assignment from last time. The importance of naming ionic compounds, or actually importance of nomenclature, period, inside the lab. Because a lot of times when you guys go to look at the actual chemical labels, it may not have the compound on it. It may just simply name the name of it. And if you don't know the name, you could very easily grab the wrong chemical. So be very careful of that. So once again, going over naming ionic compounds. I already went over with you guys last time on the first couple, and let's go over the last couple to see actually how you do it. So the first one, once again, this is a ionic compound. How do you tell ionic compound from basically other compounds? Ionic compound is going to be a metal combined with a non-metal. So remember, metal and non-metal. If they're sharing electrons, that's going to be a covalent bond. That's going to be a non-metal to a non-metal. And so once again, don't not get that mixed up with ionic versus covalent. So this one here, looking at the first one, hopefully you guys recognize that because that's a very common compound. That's table salt. So once again, NaCl. Remember, the first one is always capitalized. If it happens to have a second letter, that is small case, okay? So in this case here, this shows it's two distinct atoms because it's a capital N and lowercase a, and it's a capital C, lowercase l. So that's sodium chloride. And once again, when you're naming ions, or I say ionic compounds, the ending, you'll drop the ending. So in this case, it's chlorine. You're going to drop the INE, you're going to add IDE, make it chloride. Okay, number two, we did this one last class too. So that's magnesium and nitrogen. So you call it magnesium nitride. All right. I gave you guys for assignments to finish up C, D, and E. You'll notice D and E are kind of tricky there because you're going to look at it and say, wait a minute, that's the same compound, but why do you have different subscripts on it for the chlorine? Well, that's because that's actually two separate compounds and they actually are going to have different names. So in this case here, hopefully you guys got this right. It's silver chloride and it's going to be silver dichloride because there's two of them there. So make sure you guys got that right on your homework. If not, change it right now and fix it because I do want you guys to have the correct one for those. Okay, once again, if you guys forgot how the periodic table's laid out, you got mostly the metals to the left side and you got the non-metals to the right side. Right in the middle, remember the little staircase that starts between boron and aluminum? Little staircase just kind of works its way down, goes over, down, over, down, over, down. And that's going to separate your non-metals from your metals. And once again, remember your metals to the left side, non-metals to the right side. So just remember that. Second one, charge of ionic compounds. This is very important, especially when you're doing balancing chemical equations, especially for setting up the ionic compounds. And it's going to be important for our topics today when we're doing the pH. So this is extremely important. So how do we get the charges? Once again, the charges for these are going to come from the periodic table. So the periodic table is your friend here. Once again, it's going to be depending upon what column they are. So remember, columns basically go from top to bottom. And that's going to tell you what the charge is. So like I've told you guys before, starting from left to right is you start from over on the left side with hydrogen and you work over to the next column. First column is going to be a +1 charge. Second column is going to be a +2 charge. And like I've told you guys before, Skip all those ones where it drops down. Those are transition metals. Those are tricky because they can have multiple charges on them. They could be a +1, +2, +3. So once again, the standard easy ones is basically just remember hydrogen, that whole column there is +1. The second one with beryllium, that's all +2 charges. Jump across all those transition metals, get over there to boron. All those are going to be +3. And then once you get to carbon, they're not either going to be +3 or -4. So they're just going to be basically by themselves. You won't really find them in any ionic compounds. Next group there, which is nitrogen and all those other ones underneath it, those are -3. And then oxygen, -2. And then basically fluorine, chlorine, bromine, iodine, all those guys, those are -1. And then you ask me, wait, what about the very last column there? Shouldn't they be something? Well, if we just went from -3, -2, -1, I guess you can call this last column, the noble gases, a 0, because they're not going to have any ionic charges. So once again, remember, periodic table is your friends. Going back to our slides again, let's do a quick check on those answers that we had from last time. So these are the ionic charges. Once again, like I said, you get them from the table. So in this case here, it's a little tricky because Ag, that's silver, that's one of the transition metals that's in the middle. You can't really figure out what that charge is unless you see what its component is of its negative charge. So in this case, it's chlorine. You'll notice there's 2 chlorines there. Each chlorine is a -1. So remember the whole point about ionic compounds, you want to make sure they balance out and they basically go to 0 charge. So in this case, if the total chlorine goes to -2, the silver must be a +2 on that one. So be very careful with that one. Magnesium, you may recognize it's in the second column, so it's a +2. So this one's pretty much straightforward. If it's a +2, there's 3 of them. Each one has a 2+ charge. Nitrogen, it's basically in the end there, it's a -3. And there's 2 of them, so total is -3, -3, or -6. Silver, the next one, pretty much straightforward. Again, like I was telling you guys, it's a +1 and a -1 for the chlorine. And then there's sodium there, Na +1, -1. Remember the previous one with the silver there, AgCl2. That would mean that the silver has a +2 charge instead of a +1. Once again, remember, check the periodic table. Always refer back to that. These are not just numbers we're pulling up out of nowhere. They're actually from the periodic table, and it has to do with the ionization energy. So once again, metals will be positive, non-metals will tend to be negative. Simplified form. So previous slide, like I was showing you guys, that's just a simple breakdown, but when you actually present it, you would present it more like this, and that's the more proper way where you actually account for all of them. Like you'll notice for B there, it's 3 because there's 3 magnesium atoms inside that compound and 2 nitrogens. So remember that important part because we're going to be using these later on. Not necessarily 100% with the lab today, but you will have to refer back to that. And then when you do the next class, we're definitely have to go back and bring that information up again. Okay, another important thing. Hopefully you guys got this. Once again, I only worked over A last time. A's pretty simple. B and C, a little bit harder because a little bit larger numbers. You may have some complex problems with that one, but should have been able to figure out by yourself. So just real quick again, I know I went over A in the class, so I'm going to go over it again. Remember, molarity is basically moles per liter. And in this case here, for this problem, straightforward, it's 5 moles of sodium and it's 1 liter of water. So setup is just simply 5 divided by 1, or you get what we call a 5 molar solution. And that'd be a 5 molar solution of sodium there. Once again, remember when you're doing those, well, not really B, but C. When you're doing C, you're going to have to convert the grams to moles first before you divide it by the liters. Otherwise, you're going to get incorrect